approach. And the system approach does not involve the project engineers at this point. It's handled away from you. The system approach is in a lot of ways better than the project approach. You have lab accreditation. So all of the district labs participate in this accreditation with CMEC. They come and inspect each lab once a year and make sure that we are doing a good job, doing our procedures properly. And then proficiency samples are sent to each of the labs and they participate for asphalt. And now we just added aggregates for every single aggregate tester that's at the lab. So using these two things, they say, hey, the equipment's good and the procedures are being run correctly. Therefore, we don't have to go out to the projects. We know that these particular procedures are covered and that we have confidence that your quality assurance program will be good. Then at the end of the year, the MAT lab prepares an annual report to give to FHWA. But PEs care about the project. So the IA changes are, it is short and simplified and forms are fillable. There are no project tests for asphalt whatsoever. You don't have to get the drill rig out in the middle of the night. You don't have to worry about anybody taking a split sample of any kind of asphalt. That is eliminated because that is now covered under the system approach. There are no aggregate gradations. These are now system-based. That means no sand samples have to be split and compared, and no stone, no recycled concrete, no blended calcium sulfate. There is no longer density on the shoulder. It's just on the roadway. And density is now required 1 per 10,000 linear feet per roadway per lift instead of 1 every 2 weeks, just to have a more set way of handling the quantities that were required. The lab creates the IA sampling plan. This first thing is important. If it's not an NHS or National Highway System project, then IA is not needed on that project. If it is too small, if the project is too small, then IA is not needed on the project. When I say too small, you go to this minimum quantity trigger. For embankment, it's 5,000 linear feet, base course 5,000 linear feet, and structural concrete 500 cubic yards. So if your project does not have anything over this trigger, then you don't have to do IA. It's checked too small, you never see this report, and that's the end of it. But if the IA is needed, the lab engineer checks this box, fills in your header information here, project engineer name, lab engineer name, and date. Then the lab fills in the project quantity here and the number of samples required and signs it as the initial sampling plan and sends it to you at the pre-con or however you do that. But he or she gives you this sheet so that you know what's coming up. We'll go back over this, that schedule a little more later. But your job is really to notify the lab of construction activity. This is your main job right here, is just to communicate with the lab so that they can come out and take the samples. So when they come out, they do a side-by-side sample of IA versus acceptance sampling. Your people are doing acceptance testing, the lab people are doing the IA testing. And those two test results are compared to see if they met the criteria. For embankment, classification is for soil only, not non-plastic embankment. Since non-plastic embankment is technically an aggregate, then that's covered under the system approach. So you do soil only, you do density. Here you run a side-by-side test with the lab out in the field. Base course is density only, because base course is either soil cement or aggregates. The aggregates are covered elsewhere, and the density is the most important test to do with the rest of it. So run side-by-side tests with the lab. Again, it's got to be different equipment. So 2 different nuclear density devices and different personnel. Then structural concrete, slump and air, run side-by-side test with the lab. 2 sets of slump cones, 2 sets of air meters, and the cylinders make companion samples from the same material. We want the material to be as consistent as possible. it's really just a split sample. It's like you're just either retesting the same material or taking a very close side-by-side sample. The lab then takes the test results back and plugs it into our nice fillable form on the intranet. Your sample ID information goes here for IA and acceptance. This is a density test, so your density goes here and here. The difference is computed for them. The tolerance is set at 3 in the IA program. And then this automatically says whether it verifies or does not verify. If it doesn't verify, then the lab has to conduct an investigation. And that's when they may call you back to try to see what happened, or they may take another test. Then there's corrective action spot here. So we have a form for each of those 3 tests, but I just wanted to show you this one. Then at the end of the project, the lab engineer puts number of samples taken and number of samples verified. The lab engineer signs it and dates it. And that is the completed sampling plan. You have initial and completed. It's all in one form. Then the lab engineer fills out the independent assurance certification. Here's the header information. Here's the signature. This verbiage here comes straight out of the CFR, Code of Federal Regulations. We send copies now to the materials engineer. That's me. The assistant district administrator of engineering, the project engineer, and the FHWA representative. If there are any omitted tests, this is kind of like errors and omissions, then the lab engineer will provide an explanation and the corrective actions. And then the non-verifying tests can be handled here or on those individual sheets as the tests are being completed. So this is so much easier. The project engineer duties are receive the IA sampling plan from the district lab, notify district labs to schedule the IA testing for embankment, base course, and structural concrete. And a question that keeps coming up, what about existing projects? Existing projects use the old IA program, new projects use the new IA program, except you can discontinue all project-based asphalt IA sampling immediately. That's because we've been doing the asphalt system approach for a couple of years now. So we've been double dipping. We don't need to continue any project-based asphalt sampling. And before we get to future wishes, I'm going to go back to this. Tim Coleman, I'm sorry if I forgot your name, but you just sent me an email about this. This is an embankment density is 1 per 10,000 linear feet per roadway per lift. And he was saying it would be great if we knew how many lifts so we could go ahead and totally determine the number of samples required. And that's not a bad idea. Is there an average number of lifts that you think would be appropriate? 2, 3? Because really we're just demonstrating to the feds that we can do this, and we've checked it on this project. So I don't think the number of lifts is really critical. But I would love for you to send me or text me or email, not text. You can text if you want, how many lifts you think are typical on your project. And we can fix that so that it's a set number right here. Future wishes are to add soils to the CMEC and proficiency sample program for classification in the lab proctor, meaning that CMEC would go to the district labs and inspect the soils as well. And then just a thought, instead of coming out on a project, if we had once a year, each person who uses a nuclear density machine come to the district lab and do a side-by test once a year. And then we know everybody's doing it correctly and the equipment's good. Just a thought. I'm always happy to have feedback. Any questions? Comments? Well, while I have all of you on this meeting, please let us know if you ever have any samples that are taking too long to be tested. We'll be happy to look into that. Or any other comments that you have about the MATLAB. We are here to help.